Okay, welcome to this video, which is about using the tests on tables of values to figure out whether the table of values goes with a linear function, a quadratic function, or an exponential function. The order of tests really is up to you. You don't have to do them in the same order I do, but I always like to do linear first, and then if it doesn't work, quadratic, and then if that doesn't work, exponential. So for all three of these table of values, one after the other, I'm going to do the linear test. And then I'll move on to do the tests for quadratic and exponential where necessary. So let's start with this one, some nice simple looking numbers. The constant difference is the test that we're doing, and that means we're looking to see if we constantly get the same answer when we find the difference, subtract a y from the previous y. So doing that, starting over here, I'm doing -3 minus -1. And that gives me -3 plus 1, which is -2. Then I am doing it again with these two. -5 minus -3 is equal to -5 plus 3, which is also -2. At this point, I already realize it's linear, but I'm still going to do the third one. I'm going to do as many as I have, unless I have a table of values with hundreds of points in it. So the third one, -7 minus -5, is equal to -7 plus 5, which of course is also -2. I am constantly getting the same difference, therefore this is linear, and I can stop. I don't have to do the test for quadratic or exponential. I've already proven it's linear. Let's do the linear test for this one. -16, sorry, no, I'm starting here. -64 minus -16 is equal to -64 plus 16, which is -48. -144 minus -64 is equal to -44 plus 64. I think I'm going to get my calculator. -44 plus 64. Sorry, -144. Woo! -144 plus 64 equals -80. So it didn't work. This is not linear, but I still want to do the third one. -256 minus -144 is -256 plus 144, which gives me -112. I am not getting a constant difference, so this is not linear. I say so. I'm not going to cry. I'm just going to move on and try the quadratic test with this one. But first I'll do the constant difference test for this one over here. So we have 4.48 minus 2.59. 4.48 minus 2.59 equals 1.89. Then I'm doing 7.74 minus 4.48. 7.74 minus 4.48 is equal to 3.26. Again, this is not linear, but I'm still going to do the third pair of y coordinates I have. 13.37 minus 7.74 equals 13.37 minus 7.74 equals 5.63. It's not linear. So this one's linear, and I'm going to stop with this one. But neither of these is linear, so I want to move on to the second test, which is the quadratic. And the reason I wanted to have at least 3 answers from my constant difference when I tried the linear is in case I have to do the test for quadratic where I need at least 3 of these values to work with. So where am I going to show this? This is tricky figuring out where I'm going to show it. For this one, okay, what I'm doing is I'm doing the second difference test. That's the test that I'm using for quadratic. Second difference means we take the answers we got from the constant difference and we do it again. It's kind of weird, but we can do that. So writing a little larger, I'm saying -80, that's the answer from here, minus -48, and that gives me -80 plus 48, which is going to be negative 32. Yes. And then so I'll circle that one just because it's starting to get cluttered. Now I'm doing it again, except I'm doing negative 112 minus negative 80. Negative 112 minus negative 80 is equal to negative 112 plus 80, which is negative 32. There. So I've done my second difference test, and because I keep on getting negative 32, I know this is quadratic. Let me see here. I'll put a nice cube here and circle it. And that means with this one I can stop. Because I've proven this is linear, I've proven this is quadratic. Now I'm going to do the same thing with this one and see if this is also quadratic. I'm going to have to step way over here in order to do the calculations. So 3.26 minus 1.89 equals 1.37. I'll circle that. Now I'm doing 5.63 minus 3.26. 2.37. Uh-oh, it's not the same. So therefore, this one has failed the linear test, but it's also failed the quadratic test. It is not quadratic either. Now, you might think, well, that means it has to be exponential because that's the only one left. Except that's not really true. It's true in the math course I'm teaching this, the 4151 math course, because the only ones that they expect the student to be able to do tests for are linear, quadratic, and exponential. But let's face it, there are more functions than those three in math. So I still want to prove this is exponential, and there are multiple reasons to do that. If this is part of answering a question on an exam, for example, doing the tests is analyzing the situation, and you get marks for that. So I'm not finished analyzing this situation. I can do a little more analyzing, and I am going to do the constant ratio test, the constant quotient test, and that also involves the y values, but I don't have to reuse any of these numbers this time. So where can I write the answers? I only have to do that with this one because these two are settled. We know that's linear, we know that's quadratic. So to see if this is exponential, I'll do it up here. We do 4.48, the second y value, divided by 2.59. What do I get? 4.48 divided by 2.59 equals 1.7297, etc. It rounds to 1.73. So let's see, instead of circling this, I'll put a nice beautiful square around it. Now I'm still running out of space. I want to do it again, but I want to use 7.74 and 4.48. So I'm going to do it down here. 7.74 divided by 4.48. 7.74 divided by 4.48 is equal to 1.727. It also rounds to 1.73. So this is good news because this is how I know this is exponential. I am getting the same answer whenever I do these divisions. I will do the third one, the last one that I can do, just because I want to have even more proof. I'm running out of room big time. I'm doing 13.37 divided by 7.74. 13.37 divided by 7.74 equals 1.727. It's rounding to 1.73 again. This is kind of what I expected. So we have passed the constant quotient or constant ratio test. Therefore, this one is exponential. If you can do all three of those tests, then you're able to take a word problem situation in an exam, and you are able to check whether it's linear, quadratic, or exponential. Once you know which one it is, you can approach the question with the correct type of math tricks that go with that type of function, and your chances of being able to answer the question correctly go way up. Okay, that is the tests, three examples with the three types of tests. If you can do those, then your next step is to find the equations. So watch my other videos that show you how to find linear, quadratic, and exponential equations because you're going to need those too. Thank you for being here as an audience for this video. It was very entertaining for me and for you, I'm sure. Before you leave, please make sure to slap that like button so hard in the face that the like button actually spins around behind your device and comes out in front again and ends up in the same place. But at that point, the video has been liked. And also share my videos, this video and every other video I have, there are 1,200 of them, on your social media, so that everyone who goes on the internet from now until the end of eternity will encounter nothing but videos of me teaching math.